supports all network layer, basically, like all network layer protocol.
Fair enough. Yes, Lakshman, do you remember something about EAGRP?
Yes, sir. Yeah, what Tabrizali said, EAGRP is an enhanced interior gateway routing protocol. The whole version is IGRP.
Okay.
Administrative AD value is 90.
Okay.
One thing I remember is the lowest value is the best path.
Okay. Okay.
Compared to RIP, OSPF, EAGRP is the 90 value, the best one compared to RIP, OSPF. That's it.
Okay, fair enough. Okay, so what are the routing protocols you have discussed till now, guys?
We have discussed static, dynamic,
okay,
RIP.
I think you can able to see my screen, right?
Yes, sir. And OSPF, I guess. I think we have done OSPF.
Yes, yes. Because you know why I'm repeating, because you know, guys, I think I supposed to start OSPF lab also we have done, right?
Yes.
Right. So you want me to start the OSPF or can I go for EAGRP?
So OSPF notes मेरा पास नहीं था. वो remember जब जो practical हमने किया था?
हाँ. No problem. मैं भेज दूंगा आपको, कोई दिक्कत नहीं. आपको भेज दूंगा. I think lab also is there. EAGRP. I think today I want to start. Let's start because EAGRP we have done with these things. I think OSPF lab also we have done. So if you open the packet tracer, I think July batch. Static EAGRP. So OSPF lab we have not yet done. I guess. Let's see. Yes, some of the protocol we have done. No problem. So we'll start from OSPF today because EAGRP, I think we have done the EAGRP last time because Tabriz, because OSPF is quite very important.
Yeah,
we have to be understand because you know even if you go for network engineer or network support, network security, cloud, or even if you learn the DevNet, there also OSPF automations is there. You must be deep understanding the OSPF. Even if you go for system admin also, even small company, a big organization, the OSPF mandatory they have configured because it is an open source and managing the open source path first. So I want you to pay a lot of attention for you both the guys.
And RB value is 110, I guess, right, for OSPF?
110, yes, AD value. Yeah. So open shortest path first. Okay, so let me start discuss some theory part. Okay, and lab part we shall discuss tomorrow because you know from tomorrow, guys, I'll be starting early. Is it okay, right, Lakshman?
Yeah.
So I'll be start because you know we are 45 minutes late today. So we'll start early from tomorrow because you know today I'll just explain only the theory part. Then tomorrow we'll do a lot of labs. Okay, so 2 hours we are going to do the lab. Fine. So let's discuss this. So open shortest path first. Is an open standard, as I told you that it is an open standard. It works by using the Dijkstra algorithm. So this is the algorithm, so which using this is going to calculate that. Fine. So OSPF provide the following features like routing update because you know allow scalability. Like RIP has 15 hop count. So what about EAGRP? How many hop count is going to work?
90.
No, 255 hop count.
Oh, hop count, yeah.
Right? For AD for EAGRP is 90. For the
90.
OSPF, for OSPF AD is 110.
110.
For RIP, what is AD?
120.
20.
120. Administrative distance. For static routing?
1.
1.
1.
Okay, for directly connected?
0.
0. Understood?
Yeah.
So these we should remember, guys. So, the why they have come up with the OSPF, the solution is, as you know that, okay, RIP is going to work only the 15 hop count. Okay, in the production network where the network is very huge, so RIP cannot be implemented. Right? So this cannot be implemented even if you have the EAGRP, okay, so also which is going to work maximum of 255 hops. Okay, so even we cannot use the EAGRP as well. The reason why they have come up with this thing is, as we can see, has unlimited hop count. This is the main reasons why most of the organizations, any organization, guys, if you go for IT industry or healthcare or government sectors, because network has become very huge, right? We cannot go for the EAGRP and RIP, right? So most of the organizations, they are using your OSPF, and one more routing protocol is your ISIS. Inter-network system. This is one of the other routing protocols. So we shall also discuss this. Okay, guys. Support VLSM and CADR. It also support multi-vendor deployment because of the open standards. So don't think that because EAGRP was Cisco proprietary. EAGRP has been developed by Cisco. Okay, but EAGRP, what Cisco has done, I think more than 10 years ago, only EAGRP, if you want to use, they can only configure only on your Cisco devices. You cannot configure any Juniper or Fortinet, Checkpoint, or Dell, or any other non-Cisco devices. They cannot configure. So now what they have made open standard like OSPF. So now EAGRP can be configured in all the different non-Cisco devices like Juniper, Palo Alto, Checkpoint, Huawei. There's a lot of vendors are available. That's the reason is showing because of its open standard, so OSPF can be configured in multi-vendor deployment. That's one of the best features I can say, guys. Okay, the OSPF is also, we'll call it as a link state. It's going to work based on your links. Two types of packets available in OSPF, hello and LSA. Okay, I think I told you about hello, right? Is one of the name of the lady who is Graham Bell, who introduced the first communication. LSA means link state advertisement. So how it will form the neighborship? So as we can see, okay, this router send your hello message to both sides. When router sends hello packets using 224.0.0.5, this is which IP?
Multicast.
This is multicast IP, guys. Do you remember when I talked about the IP addressing? Okay, 224 to 239.0.5 is only used for multicast. I think your class C start from 192 to 223. Do you remember? This is your class C.
Yeah.
Correct. So, and 129 to I think 191 is your class B. Okay, and 0 to 126 is your class
A.
Right. So here these OSP, what it does, when it want to form the neighborship, okay, it sends what it sends. It sends the hello packet by using this multicast IP to both his neighbor. Hello packet are received by the neighbor. B will write A name and its neighbor table. What it will write in the neighbor table? This router B, it will write A is my neighbor. Same way, C also writes where it has got the routing table, neighbor table. What it writes? It writes, okay, A is my neighbor. Okay, so C also process the same way. So what it does in hello packets, small frequently issues the packet, discover neighbor and negotiate the adjacency. Because as simple as gas, because whenever you configure the OSPF, it's try to form the adjacency. It's try to form your neighborship. Verify continuous availability of your adjacent neighbor. Not only that, once it will form, it's trying to negotiate whoever has been connected in your network. Hello packet or link state, LSM means link state advertisement. Build and maintain your topology database. Hello packet are addresses by your 224.0.0.5. This is the multicast IP. So how it used to form your neighborship. As simple as gas, because someone new guy or you want to talk to him. What is the first message you pass? Hello man, hello brother, how are you? Hello, right? Hello message, right?
Yeah.
Same thing here also. Because as it is a device, okay, so it use this IP address. Okay, so use this IP address, please send to my neighbor. So I want to talk to you. So LSA, link state advertisement, and OSPF data packet contain link state and routing information that share among the OSPF routers. Okay, so after these few slides, I will explain the simple topology using OSPF configuration. Okay, LSA shared among only the router with whom it has been formed the adjacency. It will share the only updates, share all the routing updates only those it form the neighborship. Correct. When you know that person, when you form, so we'll get form the neighborship, then only you can share your complete details. Whereas your LSA packet are used to operate and maintain your topology table. It maintain your topology table means how many people has been connected. So one router has been connected, many routers. It will form your topology table. So as you know that it maintains the three table, right? Neighbor table, topology table, and routing table.
Routing table.
Yeah. So this is the quite very important three table your OSPF is going to form. So what is a neighbor table? It contains information of the neighbor. Neighbor means who is your neighbor. Just understand like this. So it will help you to understand better. So neighbor is a router which shares a link on the same network. We share the links with the same network. Another relationship is adjacency. It forms the adjacency, not necessary for all the neighbors. It will not form neighborship for all the neighbors, but to those who you want to form your neighborship, not for all. LSA update are only when adjacency is established. When the neighborship is formed, okay. So example, this is your two router. So where you connect the two routers here. So when it formed, when we send the hello message, what it does, okay, 224.0.0.5. Okay, we send the hello message by using this one. Okay, when it is formed the establishment, when you form the adjacency, what it does means LSA update will be sent. That is your LSA update. It sends your LSA updates. Then it will form you. Then it will share all your say your routing table. Okay, and at the same time it will form your topology table. Okay, and one more is which table? Neighbor table. He is my neighbor. So three table it will update by this router A to router B. So this is your router A. It form this. So B is my neighbor. Okay, B is connected to this link, that is serial interface 0/0. Okay, and routing table. So maybe I think this guy is say 110.2 or 10.0 network. This is 20.0 network. Maybe it will maintain the routing table. I hope you understand, right?
Yeah.
And topology table. So contain information about all the network path to reach to any network, right? So all LSA are entered into the topology table. Okay, in the topology tables, all LSA. LSA means link state advertisement. It maintain the topology table. As simple as just, because, when I know Tabrez, so I know from since I think 5-6 years, right? So I know Tabrez, so he's from Fiji. So now I came to know new update. What is the new update now? So now he shifted to US. He's working in America now, right? So now this is a new update. So what my old update is? Old update I know. So he's from Fiji. So he's working as a system engineer in Fiji. So now new update is, what is the new update? After communicating again. So this is called your link LSU. That is link state update. Remember, link state update means this is what it does. Every 2 seconds it will send the update. Maybe because maybe after a few years, so Tabrez will shift to New York or Washington. I don't know. Right. What I will do means we'll keep on sending the LSU. Okay. If you Tabrez has got the new update, okay, he will give the update to me. He doesn't have any new update, it will not share. Maybe he's staying in the same California, so he'll be using your LSS, link state advertisement. Okay, this is how he's going to form your table, guys. When topology changes, LSA generated and send your new LSA. Same thing, because LSA update. So if you change to California, to you shifted to Washington or any New York City. Okay, what I will do, I will generate new LSA and send a new LSA. Means topology change, right? Maybe say example, because this is my router. Okay, one more router has been connected. So this is A and this is B. Okay, so and coverage now what is in my topology table? In topology table, what it contain? I know. Okay, so B is in California. Okay, now so coverage has shifted to another city, say New York. He shifted to New York. So that I don't know. So what I will do? So this guy will send your LSU. So what is it? I got the new update. So what he will do in topology table, he will update. So B is now in New York.
Yeah.
He'll update. This is how it's going to work, guys. So on topology table, an algorithm will run to create the shortest path. This algorithm also known as SPF or Dijkstra algorithm. So this is the algorithm which will calculate automatically, because human being we can understand because he shifted to another city. So topology change, right? So what I will think in my topology table. So I know Tabrez is in California. I know. So after a few years, maybe he'll change. How would I know? Right? Because frequently, if you communicate each other, I can come to know. So Tabrez is shifting to another city. Right? Because I don't know. Because I thought Tabrez, whenever I remember Tabrez means I remember. So Tabrez is from Fiji. That's why I know. So after many years, he contacted me that I come to know, okay, fine. So he shifted to US, he's working shifted with the family. So now my topology table I will update. That should have.
Yeah.
Okay. I hope you understand this example.
It's like a backbone, Trainnig.
Yeah. When we communicate, as simple as guys. So when we frequently communicate with each other, so we can come to know what's happening in your personal life or in your professional life. Right.
Yep.
If you contact many, yeah, Lakshman. Yeah, Lakshman. Yeah. See, now, yeah. So in routing table, also known as forwarding database, generate an algorithm. So you generate algorithm is running on your topology database. Routing table for the each routing is unique. Routing table is unique for all. Okay. Where because every context details will be have the unique, right? So can we do the small lab, guys, for the OSPF configuration? Okay. So OSPF term, because Hop is also missing this class because he told I want to attend because in yesterday he has not attended. Yesterday I just explained basic things because Hopis want to attend this training. He's also planning the training center in their country. Yeah, because OSP is very important. I don't want to go ahead from here because let him join tomorrow. Maybe tomorrow he will join. So let me go for the small lab so that we can understand how we can configure the OSPF. OSPF is a very vast protocol, guys, and it's quite very interesting, guys. So let me, I think, OSP, a lot of labs I need to explain you guys. Okay. The OSPF, NSS lab, stuff, total stuff, a lot of lab.
OSPF Lab 1.
Yeah, I think this is for you. I have explained. Now this is Saturday, Sunday class. Maybe I think this is for other batch. I think this is the lab I had done last time for you guys. 100, yeah. Is forming the adjacency.
Oh no, this is the previous, I think. Yeah.
No. Show IP interface brief. Yeah, I think this is previous one.
Yeah.
I think you people forgot everything, right? 1.1, okay. Show IP route. Okay, OSPF 2 has been formed on neighborship. So I think I can able to reach. So 192.168 2.1. Yes, I can reach. 2.2 is there. Yeah. So this topology is working as you can see, right? If you check how to check the configuration, show run, right? So he has so I have configured with DSCP, and I think Clara. Oh, okay. I think this is I explained for
Class, na?
Clara. I think this is not explained for you guys. This is a Saturday Sunday where I have given for African students. Many African students they join. Loopback, okay, using loopback also I had done. So this is very good lab, guys. OSPF password is Cisco. I think can be able to do the telnet from here. I want to show you some interesting thing, guys. Okay, let me check telnet. So 192.168 1.1. I think clear are. Cisco 123. Yes. Show IP. I think the telnet, I think you are configured, right?
Yeah.
Yeah. See, guys, as you know that this CCNA coverage what you have done, the
Yes.
300.201. Okay, this is the latest CCNA what you have passed. Do you know the content? Have seen the content?
Yeah, last time you showed me.
And there is also the automation also there inside, network automation.
Okay.
And even so, you should learn the Python, this one, guys, programming.
Yeah.
Okay, so that one also I'm going to teach you guys. Network automations, this one, Python. So where we can do the Python, guys? So if you go for configuration programming, if you go to the programming, you can see the new.
Yeah.
Okay, so, okay, new, if you go, and there is a empty Python, usual JavaScript, analog. So what you want to do? HTTP, TCP, AP, these all things, guys, you are going to learn, guys. Okay, so we'll start from, if you see the Python. Okay, let me go for Python broker or client. Because still, so we can write a Python programming, we can run here. Okay, so we can install the in desktop, there is no empty file. So we'll reuse this. Okay, what is the thing is, I'll tell you that coming session. That's the reason, because I'm not going to explain today itself. So let him join tomorrow, like Hafiz also he will join. Okay, maybe one more guy also join from tomorrow. So he's from Andhra Pradesh. He already learned CCNA, so I want him to join, because so this time I'm going to add the new things as per the Cisco syllabus. Okay, so this is a new thing, guys, in programming we shall do. So let me explain like how this packet filter will be happen if you go for the stimulation. Okay, so let me ping how the packet will flow from this desktop to this laptop. Okay, so let's go. So switch will broadcast to all, and it also broadcast to router. So this all will reject this packet, because this frame, okay, as you know that it not belongs to him.
Yeah.
So now it will go to switch. Now it will go to the router. Then it will go to this router now, and we'll open that packet, guys. Okay, now we can see. So now I'll stop this. Okay, now I'll open this packet, guys. So OSI model, how it works, guys. As you know that, okay, your source IP is now it's coming back, right? Okay, let me show you here. So from where to where I have ping, I think this is IP address. What is the IP address for this? This is 1.5. 1.5. I think we should not open previous. Okay, let me open from here. Yeah, so now we can see, right?
Yeah, 1.5. Yeah.
In layer 3, okay, 1.5, the IP address from where to where I have ping. First understand this. So because this is quite very important coverage, Lashman, please pay some attention. So right now, so I have pinged from this PC to this laptop, right?
Yeah.
So this laptop IP address is 2.6, and this is your 1.5. 1.5. So we can see, when you see this IP header, this is source. SRC means source. From where I ping 1.5, destination is 2.6. So which protocol I use ICMP because of what ICMP means. I have ping. So ping is a command. It's a protocol which is used to check the connectivity between your two devices or two connectivity.
Yeah.
To check that one, it use ICMP, Internet Control Message Protocol. This is the protocol which will check the connectivity between the either sides. Okay. Now we can see in outer layer is also showing the same thing because it also works because next layer is going to HDLC or frame. HDLC means your WAN link. We'll call it as your WAN link. Okay, the serial which serial interface 0/1/0. This is the 0/1/. This is the interface. From this interface, your packet is moving. Okay, so now let's see. Go to next now. Now we'll pause this here. Okay, now we'll open now this packet now. Now see what it's showing now. Now it has reached to router 2, right?
Yeah.
Now, so we can see source remains same 2.1. So can you see who is 2.1? Who is 2.1 guys here? Very important question, guys. This is the real-time lab I'm showing you because usually for stimulation, the packet analysis, so it's not no one going to explain you guys because you are going to work with the companies and the organizations. Who is 2.1 here?
Yes,
Tabriz?
Router, I think.
yes, sir, router.
Which router?
The layer 2 router.
Means
which router? Whether
router, sir?
This router or
no,
this
no,
router?
that one not, sir. Yeah,
Here I mentioned IBM router.
No,
This
no,
is
sir.
your R1 and this is your R2.
R2, sir.
Dell router.
Huh?
R2,
The
Dell router.
2.1 is the R2 router.
Yes, we can see, right? So what is sending? It's sending the R packet. So 2.1. So Dell router, right? This is a Dell router. So this is your what is the IP address? This is the interfaces. This is the 2.1. Now source has become changed. Can you see?
Yeah.
2.1. And destination is 2.6.
2.6.
Okay, now 2.6. Now in this router, what it maintain your routing table. Correct?
Yeah.
In this routing table, 2.1 is act as your gateway. Okay, in this routing table, this router check whether this 2.6 is available in my routing table. Okay, then it will send directly to this guy. You can see this one. Let me show you the stimulation part. Let's continue. You can see it's coming down now. The packet is coming down. So now it will send only to this guy. You can see it will broadcast to all. All people will get rejected. Okay, this guy will accept. Can you see? This guy is replying. Can you see?
Okay.
Yeah.
Now we can see. Let me pause this one. Now, if you open this packet, now you can see right. It has received this one. Let me continue. Okay, so these all people are rejected.
Rejected.
So this not belongs to me. And this guy will reach here. It will broadcast here. So this, let me stop this. So what difference can you see, guys, here? Can you tell me what changes you can see here? In outer layer, you can see IP header 10.1.1.2. Destination is 224.0.0.2. OSPF hello. What is this, guys? Communication is done. First understand, because first time I have ping, only one time I have ping, right? From this PC to this PC. What I did from this PC to, I think one of this PC, I think I have ping. I think this PC.
Laptop,
Right. The
yeah.
communication, yeah. So communication is done, no problem. Now, what I'm trying to explain, after this communication, OSPF we keep on sending you a hello message, right?
Yeah.
Both the sides. So they'll send hello message. So what is going to do here? So it use these 224.0.0.5 IP address, okay, to check any updates in future. Maybe you change, maybe you connected one more router here. Maybe this guy is connected with the new department with the new router here. What it does means it will send your new LSA. It generate the new LSA and send to this guy. What it does, it will send, okay, fine, I will update my routing table. I hope clear, guys?
Yeah.
And what lab has showed you guys, this is quite very important to understand. Okay, so let me start one simple lab, guys. I'm not going to take long time today. So we'll stop the sessions another in 15-20 minutes, because tomorrow we'll do the full lab about the OSPF. Okay. How much time you have, Sabresh?
About an hour.
Yeah, 1 hour time.
Yeah.
Yeah, fine, done. Okay, so let's do the OSPF lab now. Okay, so to do the OSPF lab, guys, so let me start what I'm going to explain. Very simple lab. We'll configure the OSPF with the area 0. We'll not configure a multi-area now. So multi-area configuration, we'll do it tomorrow.
Okay.
Okay, so pay a lot of attention, guys. I'm going to use Cisco ISR router. We'll use 2 switches, some end user devices. We'll take one laptop and 1 server. Let's keep simple. So as you know, I think this is no serial model. So we'll insert serial model. I think you know, right, how to insert it. So in your company, Cisco devices are there, Tabriz?
Yes, sir.
Which devices?
We have Cisco. We have only we have switches. I would think a few switches are there and routers. Yeah.
Okay, maybe I think they are using a layer 3 switches. Layer 3 switches where we can do both routing and switching.
Yeah.
Okay, so what I am going to do, guys, this lab, let me write it down the task here. Task is, the first thing is assign IP address as per the diagram. Okay. The second thing is configure DSCP. I think
Telnet, no.
yeah, I will do Telnet as well. Okay, I will share you one very good document, guys. Please don't share to anybody. Okay, I will share you the CCNA cookbook or workbook for you guys. You have to keep practicing, guys.
Yeah.
Be serious now, because it's quite very important.
So you're going to configure dynamic routing as well?
Yeah, this is dynamic routing itself. Link state routing. This is one of the dynamic routing. OSPF single area. And fifth one is what else will do? OSPF, DSCP, Telnet, possible SSH will see, and using loopback. Okay, so this is a task. Like if you want, I'll make it bigger. Is it good, guys? Now it is so big.
Yeah, that's okay.
It's okay, right? Is it you can able to see?
Yeah,
right?
yeah.
Yeah. See, so if you want the color also, we can put the color. Okay. So this time, guys, the new things, I'm going to configure the DHCP not on the routers, guys. I'm going to configure on your
Switch.
this thing on your server.
Okay.
Okay, yeah. Let me. Okay. Okay, fine. What is the first task, guys? I must do now.
Enable. Config T. Config a terminal.
So host name I will give R1.
Yeah.
Then, so assign the IP address. So let me assign IP address here. So 192.168. Say this is my 100.1/24. And this is 200. And this will take you 10.1.1.1 class 8. This is 2. Okay, right? So we'll give automatic IP address. We'll spell this one. So first thing is go to the interface gigabyte 0/0/0. What is the IP address? 192.168.100.1. So give the subnet mask. Okay. So just say no shut. Then go to serial. Okay. What is the IP address? 10.1.1.1.
Yeah.
25000. Okay. So as you know that we have to set the clock rate here, right? 64,000 as it is a serial interface. Okay. So this is done. Exit. So do show IP interface brief. Why is showing? I have typed here show SH. So now we can see, right? So just we have configured this, all interfaces are up because you know this is down still. So this guy is still down. So we'll check this one later. Okay. We'll see this check later. Okay. So now what else we should configure? So we should create I think this 2 task is done, right? Right, as per this thing. So what we have done, we have done the IP address, DHCP will configure on this server. And now Telnet we have to configure, right?
Yeah.
So let's configure the Telnet. So how to configure Telnet, guys? Username.
Name.
Yeah. She's asking the name.
Like.
So I will give Ali. Yeah. Not Telnet. I am going to configure the Telnet, right? First, create the user. To configure, you must have the user, right?
Yeah.
Yeah. So I'll create user name Taj. Okay, and I'll give this some privilege. Privilege I will give all 15 rights. Means 15 security
Users.
access. I'm giving this one. Then I'll use secret password. I'll give Cisco 123. Very simple password. Keep it. Okay. Then create that
Line VTY.
line VTY
is 04 0 space
0 4. Then password
Cisco 123
123 login local.
Local.
That's it. Okay. So now we'll configure this one, guys. So DHCP. So go to server. This is your server service. So click on DHCP. Now it is on. So I will give, say, example. This is my HR team. Okay. Gateway. Let me give the first IP address for this. So 192.168. Okay, 100.100. So 192.168, 100.1. So 192.168, 100.1 is the gateway. DNS, if we want, we can give DNS. Okay, starting IP address will start from 192.168, 100. Let's start from
10.
10, yeah. Subnet mask 255.255.255.0. Okay, so my zone number we can give just 200 or we can give just 50. We don't have a lot of PCs, right?
Yeah.
Okay, and add. Right, the starting IP address we have given here. Gateway is 100.1. So let's see whether we are getting the IP address now.
Yes.
So I think we have got the IP address, but gateway we are not getting. Let's see that one. So this is the thing. We are getting 10.2, but no problem. So we'll get the IP address. That is not a problem. Okay, let's see this side. I think I showed you once, right? How to configure this. So 10.3, we are getting the IP address. Okay. So now what we should configure, guys? So telnet is done. Now we are going to configure your OSPF. Correct?
OSPF. Yeah.
Yeah. So go to global configuration mode. Router OSPF say 10. So we can give this one, guys, process ID. So in EAGRP, we'll call it as your autonomous system number. So here we'll call it as your OSPF process ID. We start from 0 to 65,535. Fine. So, but this ID should be same for other router to whom you want to form the adjacency. So how we should configure network? Give the question mark. Okay, network number. So I want to authorize your network 192.168.100.0. So here, guys, we must use the wildcard mask, not the subnet mask. So what is the wildcard mask for class C, guys? For the class C, what is the wildcard mask? Wildcard mask is a reverse of subnet mask. Correct?
Right, sir. Right, sir.
Do you remember? See, what is the class C. Class is subnet mask is 255.255.0. Okay. Wildcard mask is 0.0.0.0.255. 255. Tabrez, you understood, right? This one, right?
Yes.
Right. So now, what is the wildcard mask for this? 0.0.0.255. So as you can see, is asking to set the area. Okay, I'll put it in area 0. Right, and one more is 10 network. Okay, 10.0.0.0. So what should be the wildcard mask for this, guys? Tabrez, can you tell me what is the wildcard mask for this?
Uh, 0 dot
0 dot
0.0.255.255.
no. So /8, right? /8 means what is the subnet mask for this? 255.0.0.0. Right? This is your subnet mask. Right. The wildcard mask for this is 0.255.255.255. This is your wildcard mask. Understood? Tabrez understood what I said here.
Yeah.
See, this is the wildcard mask for class A, right? This is the class A IP address, right?
Yeah.
What is it? This is subnet mask. The reverse of this, what is the reverse?
0.255.
255. This is your wildcard mask. That's it. Okay. So let's do that. So 255.255.255. Okay, this also I'll put it in area 0. That's it. If you type here show IP route OSPF, it's not going to show you anything. Show IP route also is not going to show you. So it should come your OSPF. What is this? It should come this one, OSPF. Because as you know that for other router, we have not configured anything yet. So let's configure that one as well. So now I jump for the router 2 now. This new fresh router. So let me change the name. This is R2. Okay, so interface gigabyte 0/0/0. So let's say what is the IP address I must give. You can see right here. IP address, so 192.168. This is 200.1. Okay, so I say no shut. So same thing, I'll go to serial 0/1/0. So this is 10.1.1.2. 255.0.0.0. So I say no shut. Why is still down? By this do show IP interface brief. It should come up, right? This one interface. Show IP interface brief. What is the problem, guys? Why is not coming up? This interface is not coming up. So for that, what I will do, I will remove this link. I will connect once again. Say this. I think this side, I think we have not given shutdown and no shutdown. So interface serial 0/1/0 no shut. Yes. Right now it is coming up, right? Right. So do show IP interface. Yeah. So we can see now it is 2 interfaces up now. So what is the first job we should do here, guys? You configure the DSCP, same thing here. So let's go to the services, DSCP on it. I will say this is my MGMT management team. So gateway I'll give 192.168.200.1 DNS starting IP address. So 192.168.200. We'll start from 10. Subnet mask. Okay. So this guy I will give 192.168.200. Will give as a 9. 192.168.200. Okay, so we are getting the IP address. Okay, so I think OSPF we are not yet configured. You can see, right? So let's configure the OSPF now. What we did not just we configure this one, guys. IP addressing, just we configure DSCP, nothing else we configured. So now I'm going to configure your what OSPF now. Okay, so router OSPF. Okay, as you know that the router one, what process ID for the OSPF we have given, the process ID we have given 10, right? So here also we'll give 10. Yeah. So network, what is my network? 200.0. So what is the wildcard mask for this? 0.0.0.255. So we'll put it in area 0. We'll put it in your area 0, same area we'll keep it. Okay.
So it will be
area
basically
0.
like, so basically it'll be like in same area, no? Like when you're gonna configure in the real time.
Same area. Yeah, real time. Real time, there is a lot of area coverage because right now today I'm going to explain only single area. So tomorrow, that's the reason that if you understood this, because tomorrow I'm going to explain the big topology.
Okay.
Okay, so a lot of things I'm going to explain. Okay.
Okay, sir.
Yeah. So now one more network 10.0.0.0 is 255.255.255.0. Okay, no. So what is the wildcard mask for class A? 0.255.255.255. Correct. area 0. Now we'll see show IP route. You can see, right? It's loading. Can you see? Can you see? It's forming the neighborship. It's forming the neighborship from 100.1.
It's a full duplex, huh?
Yeah, it's a full duplex.
Yeah.
Always, all communication is a full duplex communication.
Yeah.
Okay. So now we can see show IP route OSPF. Okay, the neighbor network has been formed the neighborship now. Right. Okay. So after this, I'm going to start the firewall training also, guys. Maybe I think this week and next week, how much I can able to cover it. So at the same time, if possible, I'm going to start the firewall training. Right now, I am going to teach maybe your. I am going to teach like Palo Alto and Fortinet firewall. So I don't know which you people want to learn.
Palo Alto.
Okay. So let me check this one now. Okay, show IP route. Yeah, so this guy also learned the OSPF. As we can see, 110. What is this 110? This is the AD value. Can you see OSPF AD value is 110?
110, yeah.
Yeah, so we can see the OSPF. This now we can able to reach, right? So ping to 192.168, 200.1, right? So I can able to reach 200 to 200.10 because it's showing some issues, right? The gateway is not taking that gateway.
Configure.
You'll see that. Yeah, we'll configure the gateway, no problem. So as we can see, we can check from this router. So 100 dot can you ping? So ping, so 192.168, 100.1, right? So I can able to reach it.
Yeah.
Okay. Even I can access, this is a router 1, right? I can able to do the telnet. Telnet to router 1. So what is the router 1 IP address? 192.168, 100.1. It's asking the username. What is the username I have given? Do you remember? I have given Taj.
That's
And pass, yeah,
Cisco
Cisco
123.
123. Right. See, right? This is the router 2 actually, right?
Yeah.
So now we are able to access router 2. Show IP interface brief. You can see, right?
Yeah.
So this is the router 2 now. Router 1. You can able to access that. Okay. So can we access from router 1 to router 2? So telnet 192.168, 200.1. We can't access. Why?
Because we haven't configured, yeah. We haven't configured in router 2.
Yes. Okay. So if you want, you can configure. Very simple. I think if you want to configure once again, I also show you once again. Okay, create the user. So this time I will create Ali. So, okay, and privilege I will give all 15. Okay, secret password I'll give Cisco 123, same password. Okay, line VTY 04. Password Cisco 123. Okay, login local. That's it. So right now I'm in R1 now. Oh wait. Okay. When we are configuring R1 again.
Oh yeah.
What you people are doing, man? If I am doing wrong thing, means like you people are sleeping, I think. You tell me, right? Which router I am configuring telnet.
Router 2.
And that means that shows that you are not concentrating on this training. Okay, again I should configure here. Okay, so go to global configuration mode. Okay, user. I'll give this time Lakshman. Okay. Privilege, I'll give all 15. Secret password, I'll give Cisco 123. Okay, so line BTY 0 to 4. Password Cisco 123. Login local. Okay, so let's check from R1 now. Okay, I think Lakshman, right? LAX password Cisco 123. Yes, so now I can able to access your R2 as well. Exit. Same thing, I can able to access from any one of the PC. Can able to configure this. As we know that. So I know, guys, I think this is very simple lab what I explained you. So I hope this understand, guys. Do you have any questions? So everybody have the communication. So let's see this wise, these guys DSCP. So gateway is 1. Do you have any question, guys, now?
So, like in real time,
Hmm.
they usually use GNS3, not this packet tracer, right? There's GNS3 one, right?
In real time.
Yeah.
Real time, they will use real devices, not this stimulation. This is software based.
Okay.
Yeah. So I'll do one thing, guys. Tomorrow I'll explain using EVNG. Okay, there's a lot of thing, guys. So okay, let me tell you that if you check in Google, okay, network stimulation. Online, yeah, there's like GST, NetSync, Open Network Lab from UK, OpenNet. There's a lot of vendor available, guys. You can see. So one of the top thing is EVNG. So what I recommend. So even I don't know what is this. People are. This is also Basun is also old one. Okay, so I recommend to go for EV, one of the top online portals. Where we can do almost everything. Every lab we can able to do. This is they'll give rental lab because buying the device is very expensive, right? We can't buy the router and switches devices.
No, it's
right?
very expensive. Yeah.
Yeah, so it costs 4,000 to 5,000 rupees on router and switches, and firewall also $5,000.
Yeah.
Maybe I think tomorrow I will use EVNG. I will on my server here. Usually for CCNA not required because I will not use server EVNG because I have. Yeah.
Like in real time, the engineers they use like all these ones, right? The EVNG. Yeah.
Yeah, they will use EVNG because I installed everything here.
And
my server
GNS3 too
here.
sometimes, huh?
Yeah, sometimes GNS because most popular has become now EVNG.
Oh, EVNG. Okay.
Because even GNS3 I use almost 15 years.
Oh, okay.
Okay, now because like I can give the best feedback because as per the GNS and EVNG, so I recommend to go for EVNG.
EVNG. Oh, okay.
EVNG. If you go open the EVNG website, okay, there is a free community version also we can download. We can community version. If you click on this professional, so profession also we can use learning center version. So buying section. So this edition required
that's a
buy
license.
a license. This is the license one, but it has got some features. That's it, nothing else.
Okay.
Okay, we need to add the license request. They will send some file. We need to add because right now I'm using community version. I don't know what is the price for this. Let me check. And this is very good, guys. let me explain tomorrow. What is this? 1 year licensing is 14,000 rupees. This lesson unlock all pro features and 2 active administrator account section. The administrator role can manage everything of the EVNG without restriction. These include creating, deleting, and modifying all folders, lab, and nodes. Okay, so
it's very expensive. Rando, so we'll need packet tracer.
No, you can go for this one.
Yeah.
Community version. So community version, I will share you the this one. This is a free of cost.
Okay.
You can download directly.
Okay, sir.
Okay, we can download, but you must have the high-end hardware resource. We cannot install your laptop. Even if you have the 16 GB RAM, okay, because if you run 1 firewall or 2 firewall, your laptop will become very slow.
Yeah.
That's the reason. So we have the server here. So I install EVNG. So feature I'll buy this one, not now. Feature I'll make the buy because I want to give the access to my students. Some of the students they want additional features. 2,400, including 16,000 rupees per year.
That's a lot.
And here also we have to add this thing, image file.
Yeah.
If you want, you can go for this one community version. That is sufficient. The community version is free. So this we can download a Windows client for Apple, for Linux, for any other thing. You can able to carry. I'll show you this tomorrow. We'll do lab in EVNG, guys.
Okay, sir.
Okay. For the OSP of multi-area, I will do even. I require that because I am doing some experiments in DevNet. Developer networks where I'm using some Python automation programming. I required OSPF configuration. I want a big lab. That's the reason I explained today, guys. So we do hands-on for this lab, very basic lab, because tomorrow I'm going to explain multi-area. Right now, this is only one single area, area 0. Okay, in area 1, area 0, area 1, area 2, area 3 also I'll go, where we can run a lot of routers. Okay, so if you want, we can go for this.
I know.
Yeah, so I hope this is understood, right, guys?
Yeah.
Yeah.
And it's practical large के वो भेज देना मुझे.
हाँ, तो मैं ये नहीं भेजूंगा. So I'll send you the other one. So I will send you OSPF, right? OSPF lab 1. Okay, so let me. You want the commands also, right? Okay, so you want this both files, right? OSPF. Okay, I will send you in the chat box now.
TXT, I think, right, was. उसके नीचे वाला. उसके नीचे वाला.
Yes. Okay, try to open right now from your packet tracer. I hope you can able to open, right?
In the server. Yes, I can do. Yes, I can open it.
This one. On the top. So I think today he has not joined. He is not at all seen. Okay, so I think guys, tomorrow is just
Yeah.
I hope guys, I think can we
Say again, sir.